we're going to take a look at a couple other examples for solving other types of equations. And this next example is, it's actually a quadratic equation, but we could maybe solve it using an alternative method or a different approach, which is to recognize first that the bases of these powers are exactly the same, and the first power, the first exponent, is twice the second. Okay, so look at those powers and compare them. Okay, now if you notice that's the case, we're going to use a little substitution. So we're going to let some other variable, I'm going to just call it x, equals whatever the base is. In this case, 4a plus 4. And if x equals 4a plus 4, we now have an equation x squared plus 8x plus 15 equals 0, which looks a lot nicer to solve. Okay, try to factor. And we need factors of 15 that add to give us 8. And so we could try 5 and 3. And then solve each of these equations by setting them equal to 0. So x plus 5 equals 0, or x plus 3 equals 0. And therefore x is negative 5, or x is negative 3. Okay, at this point, we recognize that we have not solved the original equation. We've just solved our new equation for x, but we really want to solve the equation for a. And therefore, we're just going to take the expression that we had set x equal to, which is 4a plus 4, and substitute it back in for x in each of these equations. Okay, so either 4a plus 4 equals negative 5, or 4a plus 4 equals negative 3, and now you can solve these linear equations for a. Okay, and let's see, that would give us negative 9/4 for one, 4a equals negative 7/4 for the other. And lastly, we have a cubic polynomial, and we're trying to solve this for x. So the first thing I would try to recognize if there's any common factors, to just go ahead and divide. So we're going to divide both sides of this equation by 3. And we get x cubed plus x squared minus 9x minus 9 is equal to 0. At this point, we're going to factor by grouping. And if you recall, to factor by grouping, we first just split this polynomial down the middle and group two terms at a time. So we'll group the first two terms and factor out the greatest common factor, which is x squared. And we are left with x plus 1. Bring down that next sign and factor out a 9, but really a negative 9. And negative 9x divided by negative 9 is x, and negative 9 divided by negative 9 is just positive 1. And at this point we realize that these factors, the binomials match, which they should. And so we have x plus 1, and then whatever remains, which is x squared minus 9, is equal to 0. And one more thing, we can actually factor this second binomial because that's a difference of two squares. So we have x plus 1 times x minus 3 times x plus 3 is equal to 0. And set each of these factors equal to 0 and solve. So x equals negative 1, positive 3, or negative 3.